Hi guys. We came here to talk about a new tool that we are working on. It's called NMState, and we wanted to solve a problem of configuring the Linux networking to several products or several users of it. Some of them are here, but there are many others. So it started, I'm from the OVIRT team, and it started with the need to, everyone usually needs to handle networking through the Linux kernel and the hardware. When we started seeing what we need, we started working with ICFG files, and then we started working with IP route 2, which is the IP tooling, who knows, and the ETH tool for things like setting the speed of network interfaces. And we even reached a point that we needed netlinks. Netlink talked directly to the kernel for things like monitoring what is going on. But we noticed very fast that also there are other products or other solutions that need it as well. So there is also, for example, OpenStack, if anyone knows, which also need it. They need it for ICFG. They usually use mainly the ICFG in its case, but sometimes other stuff. Also we have a tool called Cockpit, which configures a specific. Does anyone know what is Cockpit? No. So if you want on a CentOS or Fedora system actually it works on others, but if you want to configure disk and networking and other stuff, you have like a web interface that you can configure that. It talks with dbus on the Linux and through the network manager. There is also Ansible. Ansible, does anyone know what is Ansible? Okay. So also Ansible handles networking. It uses many network NMCLI and the libnm, which is like a library that works with dbus. And there are other stuff that don't know yet that they need to handle networking on the host, like Kubernetes, for example. For now, they said they don't mind, they don't care about it, but we think they will care about it soon. And all of this is pretty complicated, causing a lot of duplication of logic, and all the tools are replicating their work, and it is not that efficient. So that's not what I meant. So what I wanted to show you now is just a quick introduction to what is NMState. So if anyone will, if you want to configure a bond with two slaves, you will need to do this on NMCLI, using NMCLI. You can look at it later. You can do this with IP route 2, and you can do this with ICFG files. It's usually 3 ICFG files, one for bond, and another 2 for the slaves. And you can do that with what we suggest, which is NMState, which you declare in a YAML or JSON format what you want, and then it just does the work for you behind the scenes. So the NMState is a layer that is above all the others, and it tries to use currently mainly. It works with libnm, which actually triggers network manager, but it also is able to do other stuff, like if it's missing from network manager, or if there is a third-party vendor, it can do the work for you and abstract the whole configuration.
So let's talk a little bit about the design of NMState. One initial goal is to really capture all the network state on Linux, make sure that everything can be addressed using this API, instead of just having partial functionality and needing different tools to configure the whole network state. And at the same time, we do not only want to allow configuration, but also allow to report the current configuration of the system in the same format, which makes it easy to build on top of this other tools that, for example, do configuration management, because you can get you can easily get a template from one system and apply it to a different one. And the whole design, the language that we are using is also declarative, which is typically also used in other configuration management systems. And we don't really care about like which format we use. We only want to make sure that it describes what you want to do. And then if you have some other tool that builds on top of it, you also know what you want to have. And then you can easily map from your custom declaration to our declaration and vice versa. And therefore, we also use, or we are inspired by the IETF Network Modeling Working Group, which is using Yang and the Netcore protocol to define a common interface to configure network appliances or network devices such as switches, routers, and so on. And since we didn't want to invent something new, we also used this as an inspiration for our setup. And the other thing is we build everything on top of Network Manager because it's already there and provides a lot of features that you would like to use. And in case there's something missing, as Eddie said, we would just implement it in nm state in case it cannot go into Network Manager, because Network Manager is supposed to be more generic, but there might be special use cases or workloads that only make sense for nm state. Another advantage that we get with Network Manager, and that's also known from the, configuring network devices, is that you can have atomic changes. For example, if you would like to move your interface from normal interface into an aggregated interface, like a link aggregation or a bridge, and something doesn't work in between, you don't want to have half-configured networking, because then maybe you cannot access your system anymore. With nm state, because Network Manager provides this, we can create a checkpoint, do the configuration, and if it fails, it will just roll back to the previous configuration. You can be sure that either the initial configuration or the other configuration will be available. And initially, we said that we would like to cover the full network state, but at the same time, it may be a problem if you don't really care about all the changes with one. With something that you want to change in your tool. For example, if you only want to add an IP address, you don't really care about defining all the other components that are involved with this device at one point. So therefore, adding support for partial states is also a design goal of nm state. Currently, we support like the basic settings as a proof of concept to ensure that we can work with everything. So Ethernet devices, of course, with basic and dynamic IP configuration, and bonding Linux bridges, and initial basic support for OVS bridges. But it will be easy to extend this to everything that Network Manager supports. And of course, we'll also add other devices if necessary. We have initial command line interface that's basically just used from our side to test the system easily. And it's already, it only has like 3 simple commands: show, set, and edit. Here we see the example of a state for the ETH0 interface, which just uses DHCP support, and at the same time you also get the IP address that's currently configured with DHCP in the same format. And if you, for example, now would like to make it static, you only need to change the DHCP parameter to false, and then apply this configuration, and you would get the same IP address, just a static one, very easily. Since it's written in Python, we also have a very simple, similar Python API where you can just get the state, change something in the configuration. Since it's declarative, it's just represented by a simple Python dictionary, while the command line tool also supports YAML or JSON, but you can just use any language that allows to express this. So you just change, for example, here for the first interface, the MTU to 9000. Then you can apply the state, and this is all that's currently required to change the network configuration. Now let's take a look at a short demonstration about how verification with rollback works. So on the left-hand side, I have Can you see this? Probably not. Can you now see it in the back? Perfect. So at the left-hand side, I have just a command line. On the right-hand side, I'm listing the current network configuration scripts on the host. And I have a demo prepared with just a simple state to configure link aggregation and the VLAN on top of this with 2 member devices. And now I can run nm state ctl set and apply this state. There you see the configuration appears. Now I will just edit the current state. And all I need is to do set absent for both the VLAN in the bond interface itself, then it's gone again. But I also want to show you what it looks like when the rollback kicks in. And I will use the MTU example that I said before and just set an invalid MTU, for example 30, which is way too low. And when I now apply this state, the system will not be able to finish, should not be able to finish because MTU 30 is invalid. And we will shortly see at the right-hand side the new configuration. And then the system verifies whether or not the state is valid and then rolls back. So there's now the configuration, and then in the end it notices that the configuration is wrong. So here we see MTU 30 is requested or desired, and the current MTU is 1500, and therefore it just rolls back. Now this, I already said that we could use the, since it's a declarative language, it's very easy to map this to other configuration interfaces. And any one of you knows Ansible. Okay, quite a few people, and are using Ansible to configure your network devices. So, and then if you also have to configure Linux devices, then you might have noticed that you cannot do it in the same way because there are generic modules that are currently available for these network devices. This is an example to maybe, for example, change the network state of a device or configure link aggregation, VLAN, or IP addresses. And with nm state, it's very easy to also implement these interfaces or these modules in the same way. So, for example, on the left-hand side, this would be a very generic configuration to configure link aggregation, which would work on any network devices as long as the device name is the same and you have a proper inventory. And then it's easy to translate this one into the nm state because it's just shifting around a few names. I also have a very short demo about this. So I now will just log out and see. Here I have the link aggregation set up. I could also set up the IP address, but there's currently a bug, so therefore I will not show this. And then on Ansible playbook with this configuration, forgot the inventory. Yeah, and here we see Ansible also managed to set up the bond interface. Here we have the web bond configuration. What's happening? The next thing that we would also like to enable you is to configure Kubernetes.
So, thank you, Tim. So another use case, except Ansible, which fits very well to nm state, at least to the declarative way, is Kubernetes. Which what? Does anyone know what is Kubernetes here? Oh, everyone. It's like the new thing. So with Kubernetes, declarative is the main thing. So it fits this scenario, and we think, at least, we have a project. I don't know if anyone knows. There is a project to raise VMs using Kubernetes. So utilizes the scheduling of Kubernetes to work with VMs. It's called kubeview, if anyone is interested. So we think that because of these needs, there is also a need to handle the host or the node configuration, the networking configuration. So we suggested this CRD as an enhancement to allow declaring what we want to have on the networking of a node. And it is separated into two parts. One is a policy, like the node net config policy, which you can set what you want for all your cluster with a matching policy, and it will auto-generate for you the desired states for each of the nodes. So we have here one example of that. This is an example with SRLV, so you can say, I want for all my cluster, for all the nodes in the cluster, any interface that has SRLV on it. I want to configure 8, I think I set it to 8 VFs. Does anyone, I hope everyone knows what the SRLV is, right? Or not? SRLV is like a special NIC that has a function that it can create virtual interfaces, but they are implemented in hardware. So this is like, you could do the same thing with an MTU. You could say each first interface of ETH0 of each node, please configure MTU 9000. It looks something like that. I will not get into the details, but you define the policy and it creates for you these states. It shows you what you wanted and what you got from the node, and if there is a difference, the controller will apply it for you. We also wanted to share that there are some challenges with this declarative thing, idea. So one of the challenges is that some of the properties that we change they also change other properties. For example, if we set DHCP enabled, we will get an IP address. So this is the desired state vs actual state. So in the actual state, we'll see DHCP enabled and an IP address. But this IP address cannot be set now because we have DHCP true. So there are other like that, like the link speed that you wanted 1 gig and you get maybe 10 gig or things like that. So that part needs to be handled currently either by a logic inside an state or by the admin that uses it. Oh, I ran away.
Okay, so I guess you're now thinking, shut up and take the money so you can get it, but you don't have to buy it. You can just download it from nmstate.io. It's available via GitHub, so all the contributions are happening with pull requests and issues there. We also have a Jira bug tracker or issue tracker where we do sprint planning, which is also publicly available. And it's currently packaged in Fedora and available in a third-party Copper repository for CentOS as well. That was this slide, which has also all the details. And the next, so the outlook, what we are planning to do as well, is of course enhance all the, add all the interfaces that you might need, or we might need, and also make sure, we already saw the current rollback automatically, but we also want to make this possible manually so that you can aggregate your changes yourself and then at the end say commit this. Then you can add additional verification. So for example, is it still possible to reach a certain system and then fall back or confirm whether the configuration is correctly. And initial idea why we are already basing our design on the network working group or modeling working group, which more or less uses netconf and Yang, is to also provide a similar interface directly via nmstate, so all the tools that provide this can be used. And we are also working on routing and firewall configuration, which is a little bit tricky because usually on Linux systems in the configuration it's, for example, tied to the interface, but in the modeling it's tied to the router itself. And of course, integrating it with OWord, OpenStack, and KubeVirt is also, we are also currently in discussion with other people about this. Thank you very much. What are your questions? If you like, you can get a little bit of candy if you need this as an engagement to ask a question.
By the way, if you are interested in Kubernetes with this, in this context, there is a talk in the Virt room. It's 4, I think.
So the question was whether or not NMState is exposing an external API or only running locally. So currently the code is only available to run it locally. So the part, for example, to expose it would be to provide a netconf interface, which would be something remotely, or using Ansible, which uses SSH as a point as well. But currently it's just locally. But others could, of course, build on top of this and provide a remote API as well.
There was plan for REST or stuff like that. So it is currently
So
in,
repeat the
we are
question. To repeat the question.
Oh, sorry. So he asked if the API is stable enough, right? It is the YAML. So we're trying now to make it stable. We are not expected to change a lot, but it is also, we are in version 0.05, so we are trying to get some feedback from the community to see how it works and if they have some special if we have some special needs, so then we may change it, but we are planning to have versioning on the API for sure.
Do you have a question? So who will now start using it tomorrow? Or at least try it? Ah, you will? Great. You can also get some candy.
Thank you very much.
Okay. Thank you.